Now, certain properties of light are explained by thinking of light as a wave, whereas certain properties are explained by thinking of it as a particle. As modern theories developed, especially as quantum mechanics developed, light was found to have a lot of similarities with electrons. So first we talk about some properties of light and try to understand how electron properties are similar to that of light. So like I said before, light has dual nature. It has a wave nature. It also has a particle nature. Now light is a form of electromagnetic radiation. Light waves compose of perpendicular oscillating waves. One oscillating wave is an electric field component and the other one is the magnetic field component. So the other thing that we also need to remember is that electromagnetic radiations move through space with a velocity of 3 times 10 raised to 8 meters per second. This is known as speed of light. This is referred to as speed of light. Now, when we talk about radiations, when we talk about waves, let's characterize waves. Amplitude is the height of the wave. So, it's the distance between the node to the crest. So, this is the node and this is the crest. So, node to the crest or node to the trough. Okay, and the amplitude is a measure of light intensity. In other words, if there is another wave which has a higher amplitude compared to this wave, if it is like this, so the amplitude is higher than that of this wave, this light would be more intense. So amplitude is a measure of the light intensity. Now the wavelength is the measure of the distance covered by the wave, the distance from one crest to the next crest. So from this point to this point. The distance from one trough to the next trough also can be noted as the wavelength of the wave. So this is the wavelength, distance between one crest to another or distance between one trough to another, wavelength, and this is the amplitude of the wave from the node to the trough. Now the frequency is the number of waves that pass one point at a given period of time. So if you take one point on the wave, the number of waves, as in the number of, so this one crest and one trough is considered as a wave. So the number of waves that pass through one point at a given period of time. So if 5 waves pass through that point at 1 second, then the frequency is 5 cycles per second. And the total energy is proportional to the amplitude of the waves and the frequency. The larger the amplitude, the larger the amplitude of the wave, okay, the more force the wave has. The more frequently the wave strikes, the total force that there is. So total energy is proportional to the amplitude of the wave as well as the. Now what's the relationship between the energy, the wavelength and the frequency? Wavelength and frequency are inversely proportional to each other, the constant being the speed of light. Constant being the speed of light. Again, why are we talking about light in this context? As the modern theories developed, it was found that light has a lot of similarities with electrons, especially the wave nature and the particle nature. So it is easier to understand a wave and then move into electrons.